I'm just going to review here some of the functional groups containing oxygen and their basic naming scheme. And as you see here, the rules pretty much follow what we looked at for the alkanes. You're going to name the base name based on the longest carbon chain that contains the functional group, and you're going to number the position of the functional group using locator numbers. So for example, if I had a derivative of butane that had an OH group on it, these are referred to as alcohols, and we always use the OL ending, so I changed the name from butane to butanol. It's butanol, and since the alcohol is on the first carbon, if I'm numbering it right to left, and that would be give me the lowest number, I call this 1-butanol. On the other hand, if I have there's an isomer of this alcohol in which the OH is on the second carbon, and I would call this 2-butanol. If I have another derivative, for example, I could have a 3-carbon chain with an alcohol derivative, alcohol functional group, but then I say I had another side group, such as say a methyl group, I would call this molecule 2-methyl-2-propanol, because I'm using the locator number 2 to indicate both the alcohol and the methyl group are on the second position. Another designation that's often used here, and it'll come up in another discussion, is that alcohols in which the OH is on a carbon and the carbon itself is only connected to one other carbon are called primary alcohols, whereas an OH that is connected to a carbon which in turn is connected to 2 other carbons are called secondary alcohols. For example, if you notice up here, this carbon to which the OH is connected to 2 other carbons, and that makes this therefore a secondary alcohol, and a alcohol in which the OH is bonded to a carbon which in turn is bonded to 3 other carbons is also called a tertiary alcohol. And notice here that in the 2-methyl-2-propanol, the OH is bonded to a carbon which in turn is bonded to 3 other carbons, 1, 2, and 3. Another important functional group are the aldehydes. And here, for example, the basic group is you always have a carbonyl carbon, which is a carbon with a double bonded to an oxygen. And this carbon is also bonded to one other hydrogen and then some other alkyl group, which I'll just designate as R. So, for example, if I were to have a 4-carbon chain that included the aldehyde functional group, and then I also happen to have, say, a methyl on the 3rd carbon over, I'm going to definitely call this a butanal. I don't have to use the number 1 here because an aldehyde by definition always has to have the carbon on number 1. So I'll name this one as 3-methyl-butanal, and I'm using the AL ending here to indicate that al ending. Some other unusual aldehydes or involving benzene would be benzaldehyde, in which case I have a benzene group and the aldehyde functional group hanging off the benzene. This particular molecule is called benzaldehyde. Another big important group here that has O in it are the ketones. And the hallmark of a ketone is it's a carbonyl carbon. You remember a carbon that is in turn double bonded to an oxygen atom, having now 2 alkyl groups on the carbon rather than, say, 1 alkyl and 1 H. Remember, that's an aldehyde. So the simplest ketone would be a molecule that we could call 2-propanone. And actually, I really just have to call this propanone because there's no way to have a ketone with 3 carbons. But this molecule, rather than being called propanone, is always referred to as acetone. A more complicated ketone might be, for example, one in which you had 4 carbons, a carbonyl on the second, and a methyl on the third. I would call this molecule 3-methyl-2-butanone. Notice what I'm doing here again is designating carbon atom number 2 as the one that has the keto group. So again, I'm naming this right to left. to give me the lowest number for the keto group, and then 3 indicating where the methyl is.